That oxygen is attached to a carbon which has a double oxygen, and that, learners, is an ester. An ester has an oxygen bridge. On the one side of the oxygen bridge, it doesn't have to be on the left-hand side, it could be on the right-hand side. But on the one side of the oxygen bridge, it has an alkyl group. This is ethyl. This is the ethyl group. We saw it yesterday. If it's attached to a chain, it's called an ethyl group. And thus, one carbon. This is the methane. And the suffix that we use, for an ester is oate. Right, so the name of the ester is just the two combined. It is ethyl methanoate. Right, and to make this reaction go faster, I can use a catalyst, and the catalyst is sulfuric acid every day. Right, so, esterification. An alcohol plus a carboxylic acid. The OH from the alcohol from the carboxylic acid breaks off, forms water, and the ester that forms is just as a result of that carbon joining up with that oxygen. So there's my carbon with 3 hydrogens. There's my carbon with 2 hydrogens. Joined to that oxygen, and that oxygen, the next carbon has a carbonyl group, and there's the H. So it is very, very simple. One more thing. Let's look at the names. I have methanol. I have methanoic acid. The name is ethyl ethanoate. So the first part of the name of the ester comes from the alcohol. The second part of the name of the ester comes from the carboxylic acid. So if I used propanol and butanoic acid, my ester would have been propyl butanoate. So depending on what I use, if I have the 2 ingredients, I can tell you exactly what ester I will form. If I have the name of the ester, I can tell you exactly what the ingredients was to make that ester. So I'm going to give you some time just to write this down, and then I'll do 2 more examples on the board, just so that we can consolidate esterification.
Switch up the mic. And more like
The act learners, can you please put up your mics?
Thank you.
The board. Right. Let's put the carboxylic acid on the side for the moment, just so that you know that the alcohol is not necessarily on the left hand side. So this is pro and 1-ol, and I'm reacting it with 1, 2, 3, 4, just for good measure. So, this is propanoic acid. I forgot. And this is but-1-ol. Right, if we look very carefully, I once again have an alcohol and a carboxylic acid. Notice, once again, my alcohol is primary. So for esterification, we use primary alcohols. So for esterification, we use primary alcohols. Right, so the OH and the H comes off, and we form a water molecule. You start doing that carbon, another carbon, carbonyl, and I cut that off. So that is this part over here. So this part over here is just going to join it. So that carbon is going to join up over there. It still has 2 hydrogens. And we can draw the rest. Right, once I have my ester and I want to name it, if I look at the ester, that is the oxygen bridge. On the one side of the oxygen bridge, could be on the left, could be on the right. In the previous example, I drew it on the left. I purposely drew it on the right. That is butyl group. Remember, with 1 carbon, it is methyl. With 2 carbons, it is ethyl. With 3 carbons, propyl. With 4 carbons, it is butyl. And with the naming, that comes first.